right, we are on Unit 2, Matrices. This first lesson that we're going to do today is all like vocabulary stuff. You're not going to need a calculator for any of this. So a matrix is an array of numbers. Basically a box with a bunch of numbers in it. You've seen these on your ACT papers. I told you that we would be getting to that next unit. A matrix is divided into rows and columns. Which way do you think that rows go? Left and right. And columns go up and down. When we ask for the dimensions, that's asking basically for the number of rows and columns. So we would give a number of rows with an X, and when we're saying that, we would say that number by, like wood, you have a 2 by 4. Okay, so a number of rows by a number of columns. So your dimensions might be 3 by 1, 2 by 7. It could be anything. So what are the dimensions of matrix A over here? The rows go left and right. So this is a row. This is a row. The columns go up and down. C, C, C. So how many rows does it have? And columns? 3. So we would call it a 2 by 3. Each number in the matrix we call an element. Elements have names. We name them. We usually use a lowercase letter to name the elements. And then specifically, they get a position. So like the position tells us which row they're in, which column they're in, and we use a subscript for that. Subscript is a number in the bottom corner. So like an exponent is a superscript, it's in the top. A subscript is at the bottom. So one element might be element B. This is not B12. It's B1, 2. Sometimes there will be a comma between the 1 and 2, but not always. And so if we're finding B1, 2, we're looking in matrix B for the element that is in row 1 and column 2. So we're going to go over here to matrix B and look. This would be row 1 and this would be column 2. So row 1, column 2. Which number was in my overlap? -8. So we're going to do some examples. I want you to work on questions 1, 2, and 3. All right, so number 1, what did you get for the dimensions? 2 by 2, very good. Matrix B has 2 rows and 2 columns. What about matrix C? It's a 1 by 3. It has, I can only draw one arrow going left and right, but I can do 1, 2, 3 columns. So 1 row, 3 columns. And then number 3 is a 3 by 1. So 1, 2, 3 rows and 1 column. So let's look at number 4. It says to find A 2, 1. So we're looking at matrix A for the number in the second row, first column. Second row, first column. What number would that be? 7. Good. Number 5 is B22, not B22, B22. So we're looking in row 2, column 2. What number is that? 6. Row 2 would be the second row, column 2 would be the column on the right. So it is 6. C11. -2. Very good. D13. 11. So we're in the first row, the third column over. Number 8, E31. -9. We're in the third row. It's the first number. And F21. 0. So some more just terminology that you need to know. A square matrix. It's a square, so it has the same number of rows and columns. So it might be a 1 by 1. It might be a 2 by 2 or a 3 by 3. Draw an example of a 3 by 3 matrix on your paper. A 3 by 3. I have put an example. Basically, anything that has 3 rows and 3 columns works. It doesn't matter. Those numbers could be positive, negative. Those numbers could be 5,000. Like, they don't have to be single-digit numbers. They can be big numbers. A zero matrix is a matrix in which all elements are 0. It does not matter what the dimensions of the matrix are. It could be a 2 by 3. But every element is a 0. That's a 0 matrix. A row matrix has exactly 1 row. This could be a 1 by 2 matrix, a 1 by 6 matrix, a 1 by anything matrix. That would be a row matrix. What are the dimensions of this matrix? 1 by 4. 1 row, 4 columns. A column matrix has exactly 1 column. Very good. So it could be a 3 by 1, a 7 by 1, anything by 1. So that would be an example of a column matrix. Now the identity matrix is the one that comes into play a lot. It helps us with some stuff that we're going to do later on in the unit. So an identity matrix is a square matrix. So it has to be square. It has ones in the diagonal going from the top left to the bottom right. And it has zeros everywhere else. So an example, if we have a 2 by 2, it would have ones in this diagonal and zeros everywhere else. Or I could have a 3 by 3 that has ones in that diagonal and zeros everywhere else. Draw a 4 by 4 identity matrix on your paper. I have found that it's usually easier to draw in the numbers before you do the brackets, because sometimes you make the brackets too small. So this would be a 4 by 4 identity matrix. One's going down that diagonal, zeros everywhere else.